Hello, good evening. Good evening to all of you. All right, so let's start our tuition today. Today, I am going to give away one lucky draw, but not now, at 30. So stay tuned. The lucky draw we're giving away at 30, about 8:30 lah. So you just wait. And then, so let's continue what we learned last week first. Last week we talked about physical quantity. Physical quantity can be divided to two category. One it is best, one it is derived. Best got 7: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. And derived quantity, many combination of the best quantity by multiplication and division. For example, area, for example, volume, density, force, and so on. Okay, work done, and so on. Many. All right. As long as you combine, then it is the derived quantity. But what is best quantity again? Best quantity is the physical quantity that cannot derive in other physical quantity, right? Then physical quantity not only can categorize under this way, it is also can categorize in vector and scalar. Right? Vector and scalar. Vector has magnitude and direction, right? Scalar is only got magnitude but no direction. For example, distance it is scalar, right? But displacement, it is vector. Speed is scalar, right? Velocity is vector. All right. Not only this, there is many others. All right. So hopefully you still remember. And then lastly, I taught you how to derive the unit. Okay. Hopefully you still remember. And today we are going to move to the second part 1.2 here. All right. Scientific investigation. Okay. So let's start our class on 1.2. Okay, what is scientific investigation? So first of all, you need under this topic, so what you need to focus in is how to see the graph. What is the relationship of the graph? So we called it a relationship of the graph. So the relationship between the y and x. What is the relationship? If you see it is go through 0 and then it is a straight line, so we can call it as y. Y is directly proportional to x as long as it is straight line go through 0. Okay, if it is a straight line but it is not go through 0, we call it as y is linearly proportional to x. Linearly proportional to x, which is it is not go through 0. Either this way or this way also can, right? As long as it is not go through 0, then okay, right? Linearly proportional. Linear mean it is a straight line. Okay, now if the graph come into this way, it is called inversely proportional. Y is inversely proportional to x. Y is inversely proportional to x. Make sure you see this one, it is going down, but it is not touching the y-axis. It is called inversely proportional, right? Okay, now if the graph come into this way, so you see this one is y, this is 1 over x, 1 over x. So we can say y is directly proportional to 1 over x. All of this previously it is y and x, x and y, x and y, x and y, x and y, x and y. So this one is 1 over x. So this is directly proportional to 1 over x. And it also can call y is inversely proportional to x. Y is inversely proportional to x. Another word. This one and this one, the graph, it is the same. Right? It is the same. Now, if the graph going down into this way, we can say y is decreasing with x linearly. Alright, so y is decreasing linearly with x. Okay, and then next, if this one it has no pattern, alright, or this way, you can say y is increasing with x. Y is increasing with x. No specific pattern. Alright. So, and if it is going down this way, it is called decreasing with x. Y is decreasing with x. And lastly, y is decreasing with x this way. But you tell me, Jaegu, this one isn't it the same with inversely proportional? Yes. But this one is not touching the y-axis. But this one, it is touching the y-axis. When touching the y-axis, I told you it is cannot call inversely proportional. So it is decreasing with x. Hopefully you know all of this pattern because of it will ask in paper 3. Paper 3, sometimes they will ask you one question: what is the relationship of the graph? You need to answer. What is the relationship? Okay. Now the next thing is I want to teach you how to find the gradient. Right? The gradient of the graph is you can simply take 2 points in the graph, in the line. Right? As long as it is on the line, right? On the line, so you can take it, and then you can take the coordinate of xy here, xy here. All right. So now you can use the y1, y2 minus y1 divided by x2 minus x1. Right? You just simply take this one minus this one, this one minus this one over. Then you will get your gradient. The gradient of the graph will be the same as long as it is a straight line. Right? You don't care whether, teacher, I take this point can or not. Alright, x3 and y3. Can or not? Yes, can. y3 minus y1, x3 minus x1. As long as it is a line on the line, then okay already. It will be the same. Right? The value of the gradient will be the same. So this one, because of it is directly proportional, so it goes through 0. So the formula is y is equals to mx. Alright, mx only. Right? No plus c. But if anyhow the graph it is not go through 0 like this. Alright, the gradient I taught you already, it is the same. Now if it is not go through 0, the graph formula is y is equals to mx plus c. Where this is the y, this is m, it is gradient of the graph, which is you can calculate it this way. This is the x. And then plus c. C is y-intercept. Y-intercept this value. For example, I take it into this way. This one I don't want to put it as y and x. I put it as p and q. Okay. Now let's say this way. 3. There is a coordinate. For example, 6, 9. Okay. So now I want to write this formula. So this formula is y is equals to mx plus c. So I need to find the m first. M is this coordinate. Right? At the y-axis, x is 0, 0, 3. So this coordinate. So I want to find the m first. 9 minus 3, it is 6. 6 minus 0, it is 6. So the m, it is 1. M, it is 1. So y is p. M, it is 1. X, it is q. Plus c. C is y-intercept 3. So p is equals to q plus 3 is my equation. Right, this is how you build it. Now I don't want to go into detail because of the most important thing it is how to do the graph, right? How to get the mark from the graph. And it is very, very important in paper 3 because of this paper 3 content of 15 marks here. This one got 15 marks, so you need to know how to score, right? But you are in Form 4, not so urgent yet, right? When it end of the Form 5, yeah, this one is very, very important. So I take one example of this experiment to investigate the relationship between the oscillation period T of the pendulum bob and the length of the pendulum bob L. This is L, not I, L. Okay, now here, this is how you set up your experiment, and then this is the list of apparatus. You got retard stand, G clamp, string, clamp, tripod stand, stopwatch, and so on. Okay, some of the students will ask me, Cikgu, do we need to memorize this? Right? No need to memorize. There is a way to write it, right? There is a way to write it. So the mark, it is given according to the way that you write it. For example, how are they going to give the mark? So they are going to give 1 mark to where is the manipulated and where is the responding variable. So if you write the manipulated and variable in and the responding variable in, then you should be able to get the marks here. Okay. Now, the pendulum is displaced to one side for 10 cm distance and then released so that it can oscillate. So, of course, you ask me, Cikgu, apa itu oscillate ho? Okay. If you don't understand what is oscillate, so this is the pendulum bob. Alright. So, I am going to put it to here, 10 cm. Right here to here, 10 cm. And then, what I do is I let go, release. This is called 1 oscillation, 2 oscillation, 3 oscillation, 4 oscillation, 5, 6, 7, 8, 9, 10. Alright, it oscillates. Okay, so the time for the 10 oscillation T1 is recorded by using your stopwatch. Once the time you got the 10 oscillation, you press the stopwatch, so you will get this value here. Alright, maybe this. Alright, how many seconds? Maybe 6 seconds ka, 8 seconds ka, 10 seconds ka, 20 seconds ka. You record it. After that, you repeat the experiment with 20, the length. At first it is 10 cm. This length is 10 cm. Now you do 20, you do 30, you do 40, you do 50. So the way to get the mark is this one no mark, right? This one no mark. And then the first one, it is manipulated, right? Manipulated. So what is a manipulated variable? Manipulated is length with the value 10 cm. 10.0 cm. Right? Manipulated variable. And then this one, it is responding variable. Right? Responding variable. Tell them how to get the responding variable. And then repeat your experiment with manipulated variable. Repeat the experiment by using the manipulated variable. Of course, you are telling me, Cikgu, how do we know what is manipulated variable and what is the responding variable right now? Okay. In the question, they will ask, and then how to know which one is manipulated variable and which one is responding variable? You go to the question. Normally, the question will give you, right? So now, experiment to investigate the relationship between this one and this one, right? One of it is manipulated variable and one of it is responding variable. So you need to identify which one is manipulated, which one is responding. But teacher, I still don't know which one is manipulated, Which one is responding? So you go to the graph. In the graph, they will ask you, plot a graph. So when you plot a graph, this is the y-axis. This is the x-axis. Alright? So y-axis here, it is t squared. This one is L. Right? They ask you to plot this way. So this one, the y-axis, it is your responding variable. Not enough space. Alright. I use responding variable. Alright. X-axis is manipulated variable. So you know this. Right? You know this. Come back to here. Come back to here. So what is a manipulated variable? Right? Oh, here. Oh, so manipulated variable, you need to copy everything here. The length of the pendulum bob, comma L. Even comma L you also need to put in. I will tell you why later. Length of the pendulum bob L. Right? So the responding variable is oscillation period T of the pendulum bob. T. You just copy. Alright. Don't ask me, Cikgu, why the T in the middle? Alright, they put in the middle, you follow. You don't use your own words. Alright. And then teacher, can I don't copy? You put it on your own. Yeah, can copy. You don't want to copy. Letter, you write like teacher, I write length of the pendulum. Can or not? You don't write L, can or not? Can. Alright, can. Depend on the teacher. Alright, you don't write L, can or not? You don't write T, can or not? If you don't write L and T letter, it is not so good. I'll just tell you not so good. Later I'll tell you why. Okay. Now, the period of oscillation T is given as T mean divided by 10. And then T mean is equal to T1 plus T2 plus over 2. Apa ini, cikgu? Alright. I also don't know what this is. Right? Later, then you will know what is this. Okay. Now, like what I do is, first time I do the experiment here, the first time, this is the second time. So I do the first time 10 cm, 10 cm, and then the reading is how much? Right? I do this on 10 cm, I let it swing for 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 oscillation, I record. Right? So, 6 seconds. This one is about 8 seconds. So I'm going to write down. I write down first 6 seconds and 8 seconds. Yeah, I want to teach you the decimal letter. Right. Nearly forgot. This is 9 seconds. 9 seconds. This is 9 seconds also. Let me see. Not so clear. This is 9, yeah. This is 9 also. Right, this is 10. This is 11, 12. 12, 10 and 12. 10 seconds and 12 seconds. This one is 13. This one is 13. 13, 13. And then this one is 15, 15. Okay. Now, I nearly forgot to teach you what is the decimal. Okay. Now, teacher, the decimal here, if I don't write, correct or not? Right? I write this one 10 cm, betul tidak? 10 cm, wrong. Have to write 10.0. Now, how about teacher? I write 10.00 cm. You said need decimal. I add in 2. Wrong. Now, how do I know how many decimal in this case? Alright. So, now I am going to show you a ruler. Okay. So, we go and find a ruler. Now, here, this one the most, this one this one easy to see. This one okay. This one is 0 cm, 1 cm, 2 cm, 3 cm. This one is your ruler. Normally it is like that. 0, 1 cm, 2 cm, 3 cm. Right? So can you read 1 cm? Yes. 2? Yes. 3? Yes. 1.1 is here. 1.1. Right? Very hard to see. Very small. 1.1. Right? This is 5.1 cm. 6.2 cm. Alright, so you can read 1.1 cm? Yes. Right, you can read 1.11 cm or not? Tell me. 1 cm is here. I move it already just now. 1 is here. 1.1 is here. 1 is here. 1.1 is here. 1.11 cannot. So cannot 2 decimal. So this one, how many decimal? 1 decimal. So your ruler or 1 decimal. Right? Ruler, that's why 1 decimal. How about stopwatch? Stopwatch. Okay. Stopwatch got many kind. So this kind, it is like, for example, this one. I use this one for example. Let's say this one. Okay. Now, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Alright. 6, 7, 8, 9, 10 seconds. Alright. This is the one that we are using here. Here. Alright. This one exactly the same. Alright. So you can read 1, you can read 2, you can read 3. Can you read 1.2 second, 1.3 second, 1.4 second? Cannot. But you will tell me, Jegu, this one isn't it can? Yes. Alright. So this one is like when you only 30 seconds. When more than 30 seconds, then it will go 1 round. Alright. 1 round is 30 seconds. So more than 1, then it will round off like 1. So this one, it is, we don't read this one. For example, what is this? Like for example, it is 1. For example, it point to here, right? Point to here. Right? This is 6 seconds. And then after 6 seconds, this one will move 6.5 seconds. It is 6.5 seconds until here. So we normally 6.5 will round off to 7 seconds. So we don't use. But anyhow, if your stopwatch is this kind, digital stopwatch, okay, so you can have 2 decimal. You can have 2 decimal. But not like that 10.50. No. Alright, how to convert it? For example, this one is 10 seconds and 15. Alright. Second. So this one is, you need to convert this one 15. 15 divided by 60. Convert this one to second. Right? This one is millisecond. Not millisecond. Whatever lah. Alright. So 0.25. So your time taken is 10 and 15 here. 10 and 15 here is 10 and 15 here. Tell you this is 10.25 seconds. Okay, you need to convert. That's why we use this one. Alright, see which one do you use, right? So your decimal depend on what kind of stopwatch, what kind of ruler, what kind of measuring instrument that you are using. Right? Okay. Now after this, what what would they ask us to do is they will ask you to tabulate your data into the table here. So when you tabulate your data, left hand side here, left hand side must be manipulated. Manipulated. Right? Right hand side, then it will be responding. Responding variable. Okay. Now they ask you to tabulate T1, T2, T min, T square, all this. Alright. So first of all, you're manipulated. Go back to see what you manipulated again. Length of the pendulum bob. Now, length of the pendulum bob, I am going to write L here. With the unit stroke in cm. Length, right, in cm. Here. Of course, you'll ask me, Jegu, do I need to write length, the full thing here? Length of the pendulum bob in full. Here, no need. Why? Okay, if you want to write, length of the pendulum bob in cm, so it will be so messy here, so hard for you to see. Alright, so if you want to write, make sure the space is big enough, then okay lah. Right, but of course, the next thing you ask me, if I write L, macam mana cikgu saya tahu itu L apa ho? That's why, you see, you ask your teacher whether, do you read this comma L? Now, what is L? You ask me what is L? Length of the pendulum bob. What is T? T is this. That's why, if you don't comma this, then here you need to write the full one. Do you want to run to write the full one? You don't want, right? You don't want. I also don't want. So, you must comma there. Right? This one, comma L to show them what is this. Okay? Next one is T1, T2, T min, T square. Alright? So, I'm going to put it in. T1 in second. T1 in second. Right, T1, T2, T min in second. T min in second. And then T, this one is T. T only in second. Lastly, this one is T square in second square. T square. So this one is second square lah, of course. Okay. T1, T2, T min, T, and T square. Of course. Now we are going to put in the value. The value here it is 10, length is 10, 20, 30, 40, 50. Alright. So here it is 10.0. If you don't 0.0, it's considered as wrong. Oh, okay. This one you can no need to copy. Just listen only. I'll do it. I'll put the graph. You just listen. What is happening here? What to do? What should you do? You just listen. Right? You no need to copy. These notes I will put it into the group letter. Okay. Now T1. Okay. I have read it 6 and add. How many decimal? This one no decimal. 6 and add. Okay. First one you take it is 6. Second tag it is here T2. I'm sorry. T1, T2 T1, T2 Alright, 6 and add. Okay, I'm gonna put it in 6 and add. No decimal. When length is 20, you do it 9 and 9. Right? 9 and 9. When third time you do it, 10, 12. And then 13, 13, 15, 15. No decimal. Alright. After you have tabulated in the data, now T-min. What is T-min? I don't know. Okay, I go to find here. T-min is T1 plus T2 divided by 2. Oh, your T1 plus T2 divided by 2. 6 plus 8 divided by 2, you get 7. Now, when you divide, you have to add in one more decimal. So this one 7.0. I repeat, when you divide, right, add one more decimal when dividing. Right? When you divide, you have to add in one more decimal. Here. So now this number have to be consistent because of this one this one plus this one divide. This one divide. Okay. Okay. 9 plus 9 divided by 2 is 9.0. And then 11.0. And then 13.0. And then 15.0. Okay. Now, next one. They ask us what is T. T, yeah. T is, I don't know what is T again. T is T-min divided by 10. Okay. T-min divided by 10. T-min here divided by 10. Okay. Why do I need to divide it by 10? Last time, the all syllabus, they do tell you, right? They do explain into detail why do you need to divide by 10. Now don't have, but never mind, I'll explain it to you why. I put it in first. So I divided by 10. 7 divided by 10 is 0.7. So because of I divide, I add in one more decimal, 0.70, 0.90, 1.10, 1.30, 1.50. Okay. Make it bigger. Okay. Okay. Now I explain this one. Why do you need to divide it by 10? So to divide it by 10, it is to make the error smaller. Right? To make the error smaller. What is error? Okay. Now I want you to record this. Right? For example. So here, from here. So one oscillation. Okay. Now when you release, you start, and then you come to here. Then you're supposed to press the stopwatch. You should stop it, right? From here and then to here. Mana tahu until here you baru stop. Your hand shake. Yeah, not handshake lah. You cannot be that accurate. Okay. It's supposed to be. For example, it's supposed to be 0.6 seconds. Right? It's supposed to be 0.6 seconds. You cannot. Sometimes, okay, your response so slow, right? Some of you, right? Here, until here you baru press, right? It's supposed to be 0.6 seconds, but you got 1.2 seconds, double, right? Right. For example, you're supposed to get 0.6, you get 1.2 seconds. Right? Your time, it is like double. It is like 0.2 become 1.2. So you plus 0.6 seconds again. So big difference. Okay, never mind. What if I do 10? For example, I do 10. Right? I do 10 oscillation. Okay. So here, 1, 0.62, another 0.63, 4, 5, 6, 7, 8, 9, 10, 6 seconds. But I got extra until here. I baru press it. Okay. So it's supposed to be 0.6 times 10. plus 0.6. Zero 0.6, I do 10 times, 6 seconds. Plus my delay. Delay is 0.6 seconds. So it is 6.6 seconds. I baru press it. So I got 10 oscillation. 10 oscillation, it is 6.6 seconds. Now 1 oscillation is, I divided by 10. 1t I divide by 10. So it is 1.1 second. No, 6.6 seconds. 0.66. So I told you 1 oscillation is 0.6 seconds. But if you do 1 time, you get 1.2. But I do 10 times, I divide the 10 again, I will get this. So which one is more accurate? This one is more accurate. That's why I need to do 10 times. 10, not necessarily 10, can be 15, can be 20. Normally, it is 10 to 20 times. Right? Depend on the question, they will tell you. So it can be 5 times also. Okay, now, lastly, t square. Right? This one, square. 7 square, it is 49, 0.49. So, let me finish first. 0.81, 1.21, 1.69, 2.25. Okay, now this one, the final answer here, final, right? Final, you are not going to use it anymore. Final, final answer is 2 to 4 decimal. It is in between 2 to 4 decimal, right? So because of this one 490 at 10120. Okay, if you don't believe, I try. 1.3 square. 1.3 square. 1.69. 0.9 square. 0.9 square. 0.81. Okay. 1.21. 1.2 and so on. So final answer 2 to 4 decimal will be okay. Okay. Now this table, it will give you 3 to 5 marks. 3 to 5 marks. I go and find where the marking scheme for you. Let me see got or not. Paper 3 don't have. Wait 2024 2023 paper 3 where basics paper 3 kertas 1 kertas 2. I want to find the what answer scheme schema kertas 3 schema. Okay, for example, but not the same, exactly the same question paper 3. Okay. Yeah. So of course this one is different in BM, and then it's different question So now you menjadualkan it, right? 4 mark in this question, right? Semua nama and symbol dengan betul, right? So they put it this one in and then this one in, right? If you don't put this one, you just put this one also can. They said semua L betul. They never said you have to write full. Alright, L betul. L betul L I V L I V R dengan betul beserta dengan unit, right? In cm beserta dengan unit. So this one will give you 1 mark. You write all of this will give you 1 mark. And then nilai adalah consistent 20, 30, 40, 50 consistent point. How many 0? 1 mark. And then This one consistent 1 mark. Now, of course, you ask me, Cikgu, this one arus, how many decimal? This one voltmeter, how many decimal? Never mind, we go and find it. Voltmeter. Normally, this one is the one that you are using. Okay? 2.1, 2.2, 2.3, 2.4, 2.5, 3. No, 2, 2.2, 2.4, 2.6, 2.8, 3. Alright? So you can read 1 decimal only. Alright? So your voltmeter, you can read 1 decimal. Okay, 1 decimal. That's all. You get it? 1 decimal. And then this one adalah betul. This one 1 mark, 1 mark, 1 mark, 1 mark each. So this one will give you 4 mark in this question. Alright? That's why you need to know how to calibrate your data. A lot of mark here. Okay? Decimal and teacher, you are so fast. Hey, I cannot memorize all. Okay? I make a short note for you here. And then now it is not so important for you to remember it. Why? Because of you haven't sit for your paper 3 yet. Your paper 3 is still long. Now I tell you how when you do your report, when you go into your lab, how many decimal you should take, you know, right? Okay, now it is not so important for you to that one, all right? Memorize this, how to score it yet, all right? You just listen only. Okay, now from 10 to 50, this is the time, t square. Okay, so I put it to here. I want to tabulate the data, and then I want to draw the graph. T square against L. Okay, first of all, I want to make it smaller first. Easier. Okay, so here, this is my y-axis, which is t square. This is L. So this is t square. T square. No need to write anything because of what is t square already in the question, right? Unit have to be in second square, and then this is L in cm. Put it in. So put in the 0. This one is 0. This one is 10, 20, 30, and then lastly 50. Okay, 50. And then here, okay, now the maximum value here, it is from 0.49 to 2.25. So maximum is 2.25. So 0.1, 2, 3, 4, 5, 6, 1.0, 1.2, 1.4, 1.6, 1.8, 2. Right? 2.2 enough. Right? So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 1.0, it is not enough. So here it is 0.2. Put in the value first. 2.25. Okay, not enough. One more. Okay. Now, of course, you ask me, Cikgu, do I need to write the title t square against, right? L and the line? My teacher said need or in form 1, form 2, form 3. No need. Because of this one, in SPM, the title already write for you. You no need to bother. Teacher, do I need to write the scale? No need. Right? Scale SPM, they don't write for you. But you don't need to write. Okay? You just need to know how to draw. That's all. Okay. The next thing it is, you need to plot in the graph. Now I'm going to plot in 0.49. Right? Here 10 when 10 0.4, 0.5. Somewhere here. Teacher, where? Okay. A lot of students got this problem. So I am gonna help you here. You calculate here how many petak is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 petak is 0.2. 10 boxes. So one box is 0.2 divided by 10. You got 0.02. Right? Meaning that one of it is 0.02, 0.02, 0.02, 0.02. Okay, so you know it is 0.02 already. 0.49, I need how many petak? I need how many boxes? 0.49. Normally I press 0.49 lah. 0.49 but never mind. 0.49 divided by 0.02. One box is 0.2 Right, 0.49 divided by 0.02. How much it is? 24.5. Next time, you see I don't press 0. Okay? I press 0.49 divided by 0.02. Right? 0.49, 0.02. I don't press the 0. You know, I lazy. Because 0.49 and 0.49, it is the same thing. Right? 24 petak. So, 10, 20, 25 petak. 24 and a half here. So, I want to plot it right here. Here, 24 and a half. Alright. Now, when 0.81, 0.81, right, 0.81 divided by 0.02, 40. 10, 20, 30, 40. 40.5, it is here. Somewhere here. Wait, not so nice. Wait. Okay. And then 1.21. 1.21 divided by 0.02. How many petak? It is 60. 60.5. 10, 20, 30, 40, 60. 60.5 it is here. Right? 10, 20, 30, 40, 50, 60. 60 is here. 60.5 it is here. Okay. Somewhere here. And then 1.69. 1.69 divided by 0.02. I get 84. 60, 70, 80, 85, 84, like here. And then lastly, 2.25. 2.25 divided by 0.02. How much will I get? 112. 112.5. Right? This one is 80. 80, 90, 100. 110. Right? 110. 122. 1, 2. 1, 2 and a half. Here, somewhere here. Right? 110. 1, 2, 1 and 2 and a half. Okay, I have plot all the 5 points in already. Yeah. Okay, 5-point plot already. Now I want to draw the line. So the line, you have to draw the best fit line. What is best fit line? Right? For example, best fit line it is you got a line here. So it not necessarily kena many points. One tidak kena. No. Not like that. Okay? So it have to be balanced. Right? Balance. The whole thing, the whole graph have to be balanced. Right? What is mean by balance? So if you got 2 at the top, then 2 at the top, 2 at the bottom. The distance almost very balanced. For example, I try to draw a line here. Okay, kena 3, cikgu. Kena 3 point But you see, the problem is when you see here, you got 1 point, it is away. 2 point, it is away. And then the distance of these 2 point, it is quite far. This one near lah. Right, this one far. So it is not so balanced. Because of these 2 point is both on the top. Unless one at the top, one at the bottom, then okay. Alright. So this is not a best fit line. Alright, no, not nice. So not nice, I don't want. So I try one more time. Teacher, I try to plot this way. Here. Okay, this one not nice. How about here? So this one, 4 point, it is at the bottom. 1 point kena. Not nice. Okay, not balanced. Okay, never mind. I try. Okay. Okay. Now, this one, you see, this one also not good. Right? Why not good? Now, 1 point is this above, right? This is a line, This one not hit the line, right? So 1 is at the top of the line. 3 is at the bottom. So 3 versus 1, not balanced. 1 is kena, one hit. So you got 3 and 1, not balanced. If you got 2 and 2, then okay. Oh, okay. Now, teacher, 2 and 2. No. Okay. Not even hit 1. Right now, I don't even hit 1, You see, I don't even hit 1 point, 1 at the top, 2 at the top. 2 top. 2 point at the top, 3 at the bottom. 1, 2, 3. Alright? So, this point at the top, you find the distance here, almost the same. These two. This one eliminate this one. So, meaning that these 2 point almost the same, the distance. Okay? Now, this one is almost same as this one. You still got 1 quite far away. Extra 1 quite far away. Not so nice. So, never mind. We try again. Okay. Try again, Okay. Now. So, how many at the top? 2 at the top. Alright. So, this distance and top, this one bottom, quite the same, The distance quite same, This one quite far. But these two near and near. Plus together become 1 far. Okay. This one it is okay. This one quite okay. Of course, you don't have the 100% answer, right? This is best fit line, so you have to find the best way to draw it. So this is called best fit. Okay, have to be balanced. Do you get it? Do you get how to get the best fit line? All right. If okay, then I start to draw. Wait. Here. Okay. 2 almost the same, right? One is this one and this one. This one and this one. 1 top, 1 bottom, eliminate. These two very near, and then it is same as this one. So this is my best fit line. This is my best fit line. Okay. Any question from here before I continue? What is the relationship of the graph? What is the relationship of the graph? This one is directly proportional, right? And then we are going to see, right here. Now, bagi tanda betul dengan tik berdasarkan kenyataan di bawah. R pada paksi Y, L pada paksi X. Do I have the paksi Y and paksi X, T square and L? Their unit is different now, of course. Right? Because of this one different equation. Right? 1 tick. So I got one tick here. One tick. And then unit pada kedua-dua paksi. Do I have it? Unit. So the unit here, second square betul. This one cm betul. So yes. Right. Kedua-dua paksi 2 tick, 2 and 3. Okay. So I need to have 2 and 3. 2 tick. And then skala seragam. So what is skala seragam? 10, 20, 30, 40, 50. 0.2, 0.4, 0.6, 0.2, 0.2, 0.2 different. You cannot like that. This one 10 and then suddenly 50 and then 40, 60, 80. No. You have to be seragam, right? Constant scale. Okay, that's it. So I add in one more tick because of I got it. Yeah, I got it. 5.5 titik diplot dengan betul. Alright. So of course I plot one, I divide one, I calculate properly. So I got it. Alright, of course. So they said 5 tick, 2. 4 plot only 1 tick. So I got 2 tick. Alright. Garis lurus, licin dan seimbang. Seimbang have to be seimbang best fit line and then licin. Alright, what is licin? I'll tell you later. So I got how many tick? 1, 2, 3, 4, 5, 6, 7 tick. Right? 4 to 5 tick, full mark, 3 mark. Alright. 2 and 3 just 1 tick. Hey, my bad lah. 2 and 3. 2 and 3 just 1 tick. 1 tick. So 1, 2, 3, 4, 5. 5 tick. 4 to 5 is 3 mark. Yeah, I get full mark. 2 to 3, 2 mark. 1 tick, 1 mark. So if you all don't know, this one don't have, you got 1 mark only. Teacher, I forgot to label my unit. Your mark is gone. Even you plot very nice, right? No. And then teacher, what is licin? Okay, the graph that I had the most one. I had the most one is like that. Wait some of you draw it this way. Okay, after that, you draw this way, and then okay. Why my ruler, cikgu, my ruler not enough long, and then if you give me this way, I straight away give you 0. Right. The question here is short of 1 tick. My one is you do this way, sorry lah. No way for you to get any mark here. No way. You get what I mean? Right? So have to be licin. Right? No such thing like not my ruler tidak cukup panjang or what. No excuses. Okay. And then later we are going to see how to find the gradient, how to find this, how to find this, how to find this. Right? So now we rest for like 10 minutes. After 10 minutes, 5 to 10 minutes after 8:30 and so on. After our rest, we are going to do one lucky draw for you, for a lucky student you. All right. So you can try to do this right now if you want. Okay, I'll see you back later. 8:30 After 8:30 we lucky draw. Okay. At 30 already. So, okay. I am going to give away one lucky draw, one ang pao. If you are not my student, you also can join at 10 ringgit, right? One ang pao only. If you are my student, you register, right? I am 28. If you are my student and you share my live stream, you screenshot to me. After that, you share, 38 ringgit. So, see which one will you get. And random number generator. How to get it is here. So now I put a number from, for example, 20 to 30. Okay, so I generate a number, right? 27, right? So you in the comment, for example, right? For example, now I put 30 to 40. Okay, my lucky number is 38, right? For example lah, right? You type in the checkbox 38. I give two chances only, right? If you kena, then you're lucky. Alright, so 30 to 40, so 32. Alright, the one that will write the number 32 here will get. So if not, I will draw for one more time, second time. Alright, draw two times for you. No people hit, then I will draw another one. Alright, two times for you. So this is how we do it. Okay, so I put the number 40 to 50. So I give you 1 minute to think of your best number. You type in the chat box, right? You put in the chat box, what is your lucky number from 40 to 50, right? 40 to 50, and then I will draw it. If you share, then you share my live stream before, then you will get this, right? If not, then you either get this one or this one. If you are my student, you register before in PTSC, now you will get 28 ringgit. Malaysia, not USD. I don't play USD. All right. Any one of you join? Don't be shy. Just type a number. Just type a number. Give you 1 minute to type your number. If no one join, then it will be forfeited. Come on. 40 to 50. A number from 40 to 50. Can be 40, can be 50. 40 to 50. 41, 42, 47, 49, 50, up to you. Any number? So kind to me. Hello? So I give you 1 minute already. None of you join. So none of you join. This activity will be forfeited. Alright? So forfeited because of you are not joining. Alright. Alright, so let's continue. Let's continue. Alright. So next one. What's the question asked? The question asks us about determine the gradient of the graph. The gradient of the graph. So how to find the gradient of the graph? Gradient of the graph, you need to draw a biggest triangle. You need to draw a biggest triangle here. I draw from here. Okay, biggest triangle. Got biggest triangle. So if possible, you just draw a 90-degree right angle for them. So make sure you know this is 90 degree, and then take this value. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 110, 112. 100. Sorry, here is 100. 100 1, 2, 3, 4, 5, 6, 7. 107. 107. So 107. One box represents 0.02. So this value is 2.14. 2.14. So I want to calculate the gradient. This equals to 2.14. 2.14 minus 0.0 divided by 50.0 minus 0.0. Okay, this is what we got. Okay, so after that you divide by 50, right? Which is this one is 50 at 2.14 minus 0 over 50 minus 0, right? So I got 0.0428, 0.0428. Zero point zero four two eight. What is the unit? Okay, what is the unit? So the unit at the y-axis here, it is second square. Here it is second square. Here it is in cm. Another word here, it is at the top here, it is second square. This is cm. So you got the second square per cm. Last week I taught you how to write the unit already. How to derive the unit. So s square cm minus 1. Cm minus 1. This is what I got. Alright, this is what I got. My gradient of the graph. Okay. Now, next thing. Find the value of the gravitational acceleration by using the formula t squared is 4 pi L over g. What is this? Right? This is the formula that they gave. So, what do we do is in oscillation formula. Okay. So if you go to find on internet here, so this one, it is not in your syllabus, but you need to know, right? The formula here, it is, right? T is equals to 2 pi sub L over G. T is equals to 2 pi sub L over G. Right? This is a formula. But what is T? T is period. G is gravity. L is length. But teacher, the one that they gave, it is different. Oh. Okay, never mind. Never mind. So I am going to square both sides here. Square the both sides here. Right? I just show you how the formula get from here. So this is t square. I square this side. This one square, I get 4. This one pi square, I get pi square. L, square root of L, I get L. G, square root of G, I get G. So I got this formula. T square is 4 pi square L over G. So this formula already given in the exam. They will give you. You don't need to worry. But it is good for you to know this formula, right, on your own. Okay, so I am going to find the value of gravitational acceleration. Okay, so I'm going to put it in. I copy the question first. T square is equals to 4 pi L over G. Okay, so this is a formula given. And from here, T square, what is the unit? T square. T is length. T is second, sorry. Second square. L is cm. So, second square over cm is this one, right? So, I bring down the L to here. Bring down to here. T square over L is my gradient of the graph. Okay. So, what I do is, I am going to bring down this one. T square against L is equals to 4 pi. So over G. This one whole thing over G. Right? The L go down already. 4 pi. L go down, left G at the bottom. So this one is my gradient of the graph. Is this one. 4 pi over g. 4 pi over g. So if I want to find g, the question said you want to find g, gravitational acceleration. Gravity go up, gradient go down. Okay. So gradient is equals to 4 pi over the gradient, which is our g is equivalent to 4 pi. 4 times pi. Pi given here 3.142, right? Over the g, over the gradient. Gradient is 0.0428. Okay. 4 pi divided by 0.0428. I get 4 pi square. I'm sorry, my square I forgot. Wait. Okay. 4 pi square. 4 times 3.142 square. Divide by 0.0428. I'll get 922.63. 922.63. So what is the unit of here? 4 no unit, pi no unit. The gradient unit is s square cm minus 1. Now it is at the bottom, mean terbalik. So this one is cm s minus 2. Right, terbalik ah. This one become negative, this one become positive. So the unit is cm s negative 2. This is what you got. The gravity. So where the gravity in our daily life, it is our gravity, it is 9.81 ms negative 2. Our gravity is 9.81. So if this one you want to change it to meter, you divide by 100. So it is 9.22 ms negative 2. You tell me, Cikgu, that is different, eh? Yeah, of course. The one that you do in the lab, in the experiment, it is not so accurate. But anyhow, you got the mark. You got the mark. Okay. Now, next question. What happened to the period of oscillation if the mass of the bulb increase? So answer is no. No change. If you increase the mass, become 10, become 20, become 30 gram, no change. Right? So this is constant variable, no change. Okay. What is the precaution step need to be taken here? So now, normally when you see this kind of question, you just say make sure the eyes are perpendicular to the reading of the ruler to avoid the parallax error. Okay, you write this. What does this one mean? Okay, meaning that this one is your ruler, right? So this one is your ruler, and then you use your pendulum, and then you start to swing, right? Ding dong, ding dong, ding dong, right? So now your eye level, it is either here or here or here, right? So you see the reading here. So if you put your eye at here, you see the different reading. Here you see the different reading. Here perpendicular, so you have to see it from here. If you see from here, the error, it is called parallax error. Not accurate. Not accurate. Alright. Alright, I have finished the whole thing already. So we are going to try to do some question from here. Okay, first of all, diagram below shows a graph V against T. Now, V, T. Now, V is what? Going up. So, inversely, no. Directly is straight line, no. The gradient of the graph. What is gradient of the graph? The gradient of the graph here is here. The gradient, how slope it is. The gradient of the graph is increasing, yes. Right, increasing. So, answer is C. The gradient of the graph is increasing. Okay, next one. Diagram shows the relationship between V and T. V and T. So the relationship between V and T can express in the equation. So this one is Y is equals to mx plus C. Right? Y is mx plus C. Y is your V. M, the gradient. Here, actually, you want to find the gradient. The gradient is negative. Right? But if you want to find the gradient, is P divided by Q. Y divided by X. So, P divided by Q. X is your T. This X is your T. Plus C. C is your Y-intercept. So, V is equal to negative P over QT. V is equal to negative, PQ, T at the top. Right? T at the top. Right? Plus P. Answer is C. Alright. Which of the graph shows a period of simple pendulum T is 2 pi set L over G? Where is the length of the pendulum? L is length of the pendulum. G is the gravitational acceleration. Just now we have just done it here. Right? T squared against L. What if they ask you to plot? It happened or not? Yes, it happened. Right? They ask you to plot in this way. T and L. And then what are you going to plot is your graph, you will get this way. It is not a straight line, it is curve. If T only. If T only, not T squared. T only. T only, you will get a way this way. This one, simple pendulum in paper 3, it came up few times in SPM. In this fire, it came up 2 times already. So, very important, you need to know. So, cannot say it will not ask in T. Alright, it can ask in T. But you cannot calculate gradient. The problem is in this question, they cannot ask you gradient. Because the gradient will be different at a different point. So, no. Yeah, it can ask. It can ask. Right? But not so good to ask. Because of they can ask you gradient. This one can ask you gradient. Okay, next question. Diagram 1 shows a graph S against T. Which of the following relationship is correct? So, S against T. Now, this one is going down. So, S is directly, no. Inversely, no. Increase, no. Decrease linearly, yes. Going down linearly. Linearly means straight line. Okay? S is decreasing with T. Diagram 1 show Y against X. Y against X. What is the graph represent? So, Y is increasing with X, yes. So, this one is Y is increasing with X. Okay? Next one. Diagram 1 shows the velocity time graph of the car, right? This way. The car is moving with this one. I haven't teach you yet, but I'll teach you in chapter 2. But anyhow, I give you the answer. So the gradient of the graph, right, is acceleration. So this one is called constant acceleration or uniform acceleration. Uniform acceleration. Uniform acceleration. Which is in chapter 2. You are going to learn it in chapter 2. Form 4. Here. Okay. So this one, velocity, time graph. So going up this way, it is called uniform acceleration. You haven't learned yet, right? You just learned the graph, but anyhow, I put it to here. Okay. Now, diagram 1 shows an arrangement apparatus to investigate the relationship between the length of the simple pendulum and the period of oscillation. So which pair are correct? So the manipulated is length. Responding, it is period of oscillation. So the constant variable is the mass of the pendulum bob. Okay. Now, inference. Diagram 2 shows the arrangement of the apparatus to study the relationship between the extension of the spring and the force. Alright, this kind of experiment you haven't do yet, but never mind. So now this one is all syllabus, but sometimes they still ask you. Alright, so inference. So if you want to write the inference, you have to write responding variable is affected or depend by something manipulated, or responding variable is depend on manipulated variable. You have to write into this way. If they ask you about the hypothesis, alright, you have to write the higher the manipulated, the higher or lower the responding variable, right? The bigger the what, the smaller the what, or the bigger the what, the bigger the what. Okay, you have to write into this way. So which one is inference is correct? The higher the force, the higher the extension. So this one is hypothesis. The extension is inversely no, directly no. Extension is depend on the force or affected by the force. Yeah, this way to write it. Answer is D. All right. Diagram 1 shows a graph y against x, y versus x. Which of the following statement shows the correct interpretation of the graph above? So the graph gradient is negative or positive. So the gradient is like that. It is positive. Positive. Go up, it is positive. Going down, it is negative. Okay. So positive, correct. The graph is gradient is negative, wrong. Y is increased with x. Yes, 1 and 3. One and 3. Which of the following statement is correct about the distance? Distance, so the length of the path traveled by the object without direction. Yeah. Length between 2 points. The length between the initial position and final position of object movement. The length of the path traveled by the object in the particular direction. No direction. So answer is A. Okay. Which of the following is not a best quantity, mean derived quantity? So that's 7. I ask you to memorize one. Right? Temperature? Yes. Length? Yes. Electric current? Yes. Best quantity. So I want not best quantity. Power. Electrical? Teacher, electrical current, it is best quantity? Yes. Current? Yes. Power? No. Power out. Right? Be careful. Okay. Now, the physical quantity represented by the gradient of the graph is acceleration for this case. right? Velocity, time graph, the gradient is acceleration. Which of the following y inversely proportional to x? Inversely. So y inversely, it is here. Y and x inversely, it is like that. But if don't have, you look at the 1 over x here. 1 over x is, this one is called inversely. This one is no, this one inversely. The answer is D. Now, which graph it is the best graph? Okay, we look at A. So you have to use a cross to plot it. So this one out. Right, this one every point it is June. Of course it is June. Yeah. If you plot like that, of course it is June. Kena here also June. Oh, cannot. So have to cross. So one top, two bottom. Okay lah. One top, one bottom, and then hit 3. Yeah, this one is nice. One top, two top, three top, one bottom, not balanced. Right, this one two bottom, not saw. Right, compared to this one. So answer, the best answer is C. Best answer is C. I check the answer 2024 SBP. SBP 2024. Question number 2. Question number 2 SBP. Question number 2 answer is C. Yeah, answer is C. Yes, correct. This one is called best fit line. Right, best fit line. Okay. Next one. Which of the following it is the purpose of plotting a graph in the scientific investigation? So giving a consistent measurement, find the value that is out of range. Yes. I will explain why. Determine the value, the average value of the experiment data. Find the relationship. So you do the plotting graph here, right? Y and X. So after you do, you know it is directly proportional or not, linearly proportional or not. What is the relationship, right? After you plot the graph, right? But anyhow, right? If the data, one of the data, it is too far away, you also know. Okay, how it can possibly happen? Okay, how can it possibly happen? Like for example, we plot the graph here. Right, 6 at this one you put in the data 6 at 9, and then here it is 90. You accidentally put it as 90, and then 10, 12, 13, 13, 15, 15. So this one you accidentally write it wrongly. So one data is very far, very high. One is 9, one is 90. So why like that? The graph like that. So the data is out of range because of your error. You accidentally write it wrongly, or you plot it wrongly, or you write it wrongly. So find the value that is out of range here. Okay, 2 and 4. 2 and 4 answer is D. Speed is defined as, okay. What is speed? Speed is chapter 2 will go into detail. Speed is equal to distance over time divided by time. If you divide it by time, we are going to call it as rate. Rate of change in distance. Rate of change in distance. Rate of change of distance, yeah. Rate of change in distance. Rate of change in velocity, displacement, acceleration, no. Okay. Diagram 1 shows a P against theta. P against theta. So, what is the relationship? Linearly. Right? Directly, no. Linearly increasing, yes. B. Decreasing linearly, inversely proportional, no. Now, which of the following is true regarding to the motion of the car with the constant velocity. The constant velocity, this one I haven't teach yet. Constant velocity is zero acceleration. I will teach you in form chapter 2, for example lah. Right here. Alright. When you see the graph here, when it is uniform velocity, is zero acceleration. I will teach you lah. I will teach you. Not now. In chapter 2. Okay. So this one is uniform velocity. It is zero acceleration. Which quantity is derived quantity? Right. Force, amount of substance, current, luminous intensity. This one is best. This one is best. This one is best. Only force it is derived. All are best quantity. Now, what is the displacement of Richard? Richard from O, and then he worked to A, and then B, and then stopped at B. He worked from A 0 to A, and then to B. So it is, what is the displacement? Displacement is where you start to where you stop. So meaning that you are moving to here, right? Moving to here, it is east. Right? How many east? 7 meter east. From where do you start and where do you stop? 7 meter east. 7 meter east toward the east. Okay. Which of the following is best quantity? Weight is derived. Volume derived. Right? Amount of heat derived. Luminous intensity, it is out. It is one out of the 7 example there. Which one is inversely proportional? This one, P and Q, inversely proportional. Inversely proportional. Which of the following is vector quantity? So mass is best. Energy, yes. No, energy, no direction, I'm sorry. Pressure, no direction. Only momentum got direction. Vector is the one that has direction. Diagram 1 shows a graph X against A. What is the relationship between X and A? X is inversely proportional. Inversely proportional. What are the best quantity in the acceleration? Okay. Acceleration, you look at the unit of acceleration. Acceleration is ms -2. This one is length, meter. This one is second. Second is time. So you got two best quantity. One is length, one is time. Length, speed, and time. No. Length and time, yes. Length and time. So I write it to here. You look at the unit. Okay. So answer is B. So a particle moved from P to Q in a time t. Which of the following correctly define both average velocity and average acceleration? So this one I haven't teach you what is velocity and acceleration. So I'm gonna skip this one. I'll teach you in chapter 2 next week. I skip. Diagram 1 shows a graph y against x. What is the relationship between the graph above? Directly proportional. Directly proportional. Okay. What is a graph P increase linearly with Q? Right? Increasing linearly with Q. B. Which of the quantity is not a basic quantity? This one spelled wrong. This one wrong. It is supposed to be best quantity. Best quantity, but we know lah, best quantity. Not best quantity. This one best quantity, yes, 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 no. Right? Answer is D. What is the suitable manipulated for the responding variable? Manipulated and responding. So this the kedua-dua buoyant, the two swings, TWO, TW, The two swinging at the different speed. What is the reason? Let's just carry the investigation. So manipulated is length. Responding is time. The period. Manipulated is length. Responding is period. We just did it just now. Which of the following is best? And SI unit is correct. Mass it is in kg. Current it is in ampere. Time it is in second. Temperature it is in Kelvin. Yeah. Inversely proportional like that. Has a positive gradient and then the inversely proportional. This one inversely proportional. Yeah, this one is inversely proportional, right? But the gradient here it is negative. This gradient is going down, negative. So this one is inversely proportional. Why? Because of this one is 1 over x. Inversely proportional. The gradient is going up. Yes, positive. Yes. Answer is C. Okay. Which of the following obey the f is equal to kx? Which k is a constant? So f is kx is like that. Directly proportional. Which is our formula is f is equals to y is equals to mx plus c, right? Plus c. C, no, you see, they don't have any c. So it go through 0. Go through 0. And then m is your gradient, constant. They said k. This is f, y-axis f. X, f is kx. It is directly proportional. Okay. Now, diagram 1 shows a V against the temperature theta. So, responding variable is your y-axis, which is V. The relationship is V is linearly increasing. Answer is D. It is found that the period of oscillation for each string it is different. Which of the following statement it is correct? The length increase, the period decrease. No, should be increase and increase. The length increase, the period increase. Yes. Okay. Now, that's all for our chapter 1. Now, thank you for the lesson and our tuition for January. It is free for January. And then this is after January, the tuition fee only 65 per month. 65 per month. And if you invite your friend to join, if you join already, you invite your friend to join, every 1 head per month, you will get 10 ringgit rebate. Meaning that if you ask 2 friends to join, your tuition fee will be 65 minus 20 every month. Only 45. Very cheap, right? You cannot find any other cheaper tuition. Maybe you can find. But anyhow, my one is very cheap already. 2 hours, right? With a lot of exercise here. Okay. So hopefully, see you in February. Okay. See you next week lah. Next week, see you free. All right. February, if you want to join, you can click the link of the link in the description there. So I'll see you again. I am Mr. Lee. I'll see you again. Goodbye. Good night.